Algebra benchmark 6.1, translating situations into equations or sentences. First problem, 6 less than twice the number is 20. Find the number. I'm going to let my x be a number, so I have a let statement. And 6 less than something is subtracting 6 from something. Twice the number is 2 times something. Is means equals 20. That's pretty straightforward. Second one's a perimeter of a rectangle problem, so I'm going to draw my rectangle first. Length is 2 more than 3 times the width. So if I let W be my width, and then right in the picture I can say my length is 2 more than 3 times that width. 2 more than 3 times the width. Oh, W, sorry. And that's pretty much it. You might want to put in, because we're talking about perimeter, the other 2 sides. And you could either write, for the perimeter, you add all the sides up, so 3W plus 2 plus W plus 3W plus 2 plus W. It just seems like a lot of work there. Equals that 68. And I would accept that, because we're not really solving these problems, we're just translating them. You could simplify it by saying 3W plus, just add all the W's together. Here's 3, 4, 5, 6, 7, 8 W's plus the 4 equals 68. That's probably what I would prefer to see. You could start off saying 2 times the 3W plus 2. There's 2 sets of the lengths plus 2 sets of the widths equals the 68. There's a few different ways to do that. But I would think just this version here, or even all the separate ones, is fine. I'm going to erase that so I get some more space for the other way that I'm going to do this problem. The other way I'm going to do the problem is just with 2 different variables, a length and a width. So here I would let's get rid of this stuff. I'll let W be my width and let L be my length. So since I have 2 variables, I'm going to need 2 equations. So I'll have a system of equations. So if I know my perimeter is 68, so I have 2L plus 2W, or 2W plus 2L equals 68. And that's great, but we still need another equation. We're going to get that from this equation, or from that sentence. So the length is 2 more than 3 times the width. Just kind of spells it out. And then you have that system. That's it. Next one. The perimeter of a triangle is 47. Okay. So I'm going to draw a triangle. Some generic triangle. The first side is 5 less than twice the second side. So I need a first side, a second side, and a third side. So I guess I'll just label first, second, third. It's obviously not going to be drawn to scale. I'm going to use a different color here so it's easier to see. The first side is 5 less than twice the length of the second side. So I'm going to call my second side, because I'm going to do something to that, my x. So let x equal my second side. And the first side is 5 less than twice the length of the second side. So I already have 2 sides labeled. And the third side is 4 more than the first side. So right here, the third side is 4 more than the first side. Now the first side is 2x minus 5. You don't really need the parentheses there. I'm just kind of grouping it off. If it would have said 4 more than the second side, I'd just put x plus 4. But because they said it's the first side, I put 2x minus 5 plus the 4. And then now the perimeter is 47, so I take all 3 of those sides. The first side plus the second side plus the third side. So that's the third side. Add them all up to get my 47. And that's fine. You can just leave it in that form. If we were actually solving, or if you want to go a little further, you could. There's 2, 3, 4, 5 x's. And then I have -5. -5 is -10 plus the 4 is -6. If you do simplify, be careful and make sure that you're adding these correctly. And that should be the end of that one. On the next, I made 2 more here, so we get some extra practice on this last one because it's a little tricky for some people. 400 tickets were sold for the dance. We have singles and couples. So I'll carefully write S for singles. Try to not to make it look like a 5. And C for couples. All right, an official let statement, so I'll just put the word let in front of it. 400 tickets were sold, so we have singles tickets and couples tickets. So I know total, singles plus couples, is 400. It's a little easier problem than the next one will be, because it just gives you the total tickets. So you just write a sum statement. Single tickets cost $5, so 5 for every single. Couples are 8, so if I add 8 for every couple, I get a total amount of $28.40. There's my system. And for this benchmark, you don't have to solve it. And this one, 40 more couples tickets, so same thing. I'll do the same let. Singles and couples. I'm going to start with the second equation just because the first one's a little tricky. Singles were 6, and couples are 10, just like the previous problem. Total amount, $1,088. Now you'll notice each one of these is money, money, money. My next line is going to be tickets, 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 tickets. And it's like here's money, money, money. They're all, make sure you group them together like that. We have 2 variables, so you need to have 2 equations. Don't try to group them into one right away. Now this is the tricky part. The 40 more couples tickets than singles were sold. So 40 more couples than singles tickets were sold. You know, right away people want to think 40 plus couples or 40 plus C because it's written right next to it. But I actually need to add 40 to the singles to make it balanced. So I take singles plus the 40, and I'll get couples. Let's just think about that for a second. If couples is more, I have 40 more couples, and I add 40 to the singles, then I should have a balanced equation, and that's what I have. So we're good. So just be careful if they try to compare the 2 to each other, that's a little trickier. Versus up here, they just give you a total number of tickets. That's a little bit easier. You can just add them up. That's it.